Welcome to today's video. You've probably connected to Wi-Fi 1,000 times without thinking twice about it. Your phone, laptop, tablet, they all just work, right? But here's something you might not realize. Every single one of those devices needs a unique address to communicate on the network. And managing all those addresses, that could be an absolute nightmare. That's where DHCP comes in, and by the end of this video, you'll understand exactly what it does and why the internet, as you know, it would be way more complicated without it. DHCP stands for Dynamic Host Configuration Protocol. Before you click away thinking this is too technical, stick with me. The concept is actually pretty straightforward, and understanding it will give you a much better grasp of how networks actually function. Think about it this way. Every device on a network needs an IP address. An IP address is basically a unique identifier that allows devices to find each other and communicate. Without one, your computer or phone is essentially invisible to the network. It's like trying to send someone a letter without knowing their street address. It's just not going to work. Now, back in the early days of networking, there was only one way to get an IP address onto a device. You had to type it in yourself, manually, every single time. This was called static IP addressing, and honestly, it was tedious. You'd open up your network settings, type in an IP address, add a subnet mask, configure a default gateway, maybe punch in a DNS server or two. If you had 10 computers, you did this 10 times. 100 computers? Good luck. And here's the kicker. You had to make absolutely sure you didn't use the same IP address twice. If you did, boom, IP conflict. Both devices would get knocked off the network until you fixed it. Imagine being the person responsible for a school, an office building, or even a coffee shop with dozens or hundreds of devices connecting every day. You'd spend all your time just assigning addresses. It's inefficient, error-prone, and frankly, a waste of time. That's the problem DHCP was designed to solve. DHCP automates the entire process. Instead of you manually typing in network settings on every device, a DHCP server does it for you, automatically. The moment your phone connects to Wi-Fi, it asks the network, hey, can I get an IP address? The DHCP server hears that request, checks what's available, and hands one over. Along with the IP address, it also sends over the subnet mask, default gateway, and DNS server info. Everything your device needs to get online is delivered in one smooth transaction. So how does this actually work? Let's break it down step by step because the process is kind of clever. When your device first connects to a network, it doesn't have an IP address yet. So it shouts out into the void. Well, technically it broadcasts a message to everyone on the network saying, I need an IP address. Is there a DHCP server out there? This is called a DHCP discover message. If there's a DHCP server on the network, it hears that request and responds with a DHCP offer. Essentially, the server is saying, I've got an IP address you can use. Here it is, along with some other settings you'll need. Your device receives that offer and, assuming it's cool with it, sends back a DHCP request message. This is your device saying, yes, I'll take that IP address. Let's make it official. Finally, the server sends a DHCP acknowledgement, or ACK for short, which confirms the deal. Your device now has a working IP address and can start communicating on the network. This whole process happens in seconds and you never even notice it's going on. That's the beauty of it. Now, there's an important detail here that makes the whole system even smarter. The concept of a lease. When the DHCP server gives your device an IP address, it's not giving it away forever. It's loaning it out for a set period of time, known as the lease duration. This could be a few hours, a day, or even longer, depending on how the network is configured. Why does this matter? Because it prevents the server from running out of addresses. Let's say you walk into a cafe, connect to the Wi-Fi, browse for half an hour, and then leave. If the IP address you were using stayed attached to your phone forever, that address would be wasted. No one else could use it even though you're long gone. But because of the lease system, once your lease expires and you're not around to renew it, that IP address goes back into the pool. The server can then assign it to someone else who just walked in. Your device will actually try to renew its lease before it expires. If you're still connected and actively using the network, your phone or laptop will quietly ask the server, hey, can I keep this IP address a little longer? The server usually says yes, and the lease gets extended. But if your device is offline or disconnected, it can't renew the lease, so the address gets reclaimed. It's an efficient way to manage a limited pool of addresses. Speaking of that pool, let's talk about how DHCP servers are set up. Network administrators configure something called a scope, which is just a range of IP addresses the server is allowed to hand out. For example, a scope might start at 192.168.1.100 and end at 192.168.1.200. That gives the server 101 addresses to work with. The admin can adjust this range depending on how many devices are expected to connect. A small office might need a small range. A university campus might need thousands. But what if you have a device that needs the same IP address all the time? Maybe it's a printer, a file server, or some piece of equipment that other devices need to find reliably. You wouldn't want that IP address changing every few hours. That's where DHCP reservations come in. A reservation tells the DHCP server, this specific device, identified by its MAC address, should always get this specific IP address. So even though DHCP is handling things automatically, you can still lock down certain addresses when you need consistency. MAC addresses, by the way, are hardware identifiers burned into every network device. They're unique to each device, which makes them perfect for identifying who should get what IP address. The DHCP server keeps track of which MAC address got which IP, and when a device with a reserved MAC address shows up, the server knows exactly what to give it. Now, you might be wondering where this DHCP server actually lives. Is it some giant machine sitting in a data center? Not necessarily. DHCP is a service, which means it can run on all kinds of hardware. In a corporate environment, it might be running on a dedicated server, something running Windows Server or Linux, for instance. But in your home, it's probably running on your router. Most consumer routers have a built-in DHCP server. That's why when you connect your phone to your home Wi-Fi, you don't have to configure anything. Your router is doing all the DHCP work behind the scenes. The flexibility of DHCP is one of its biggest strengths. Whether you're running a massive enterprise network or just trying to get your smart fridge online at home, DHCP handles it all the same way. It scales up, it scales down, and it just works. There's also something worth mentioning about static versus dynamic addressing in the real world. Static IP addresses still have their place. Servers, routers, and network printers often use static IPs because they need to be reachable at a consistent address. But for everyday client devices, laptops, phones, tablets, dynamic addressing via DHCP is the way to go. It's flexible, it's automated, and it reduces the chance of human error. One more thing that makes DHCP so useful. It doesn't just hand out IP addresses, it also provides other critical network information. When your device gets an IP address from a DHCP server, it's also learning the subnet mask, which tells it what portion of the IP address identifies the network versus the individual device. It gets a default gateway, which is the address of the router that connects your local network to the internet, and it gets a DNS server addresses, which are the servers that translate website names like google.com into IP addresses your device can actually use. All of that information is bundled together and delivered in one go. Without DHCP, you'd have to configure all of that manually on every device. With DHCP, it's automatic, instant, and invisible. So to sum it all up, DHCP is a protocol that makes modern networking manageable. It automatically assigns IP addresses and network settings to devices, uses a lease system to efficiently manage address availability, and works across everything from home routers to enterprise servers. It's one of those technologies that quietly powers the internet, and most people have no idea it even exists. But now you do. You know what DHCP is, how it works, and why it matters. Next time you connect to a Wi-Fi network and everything just works, you'll know there's a DHCP server in the background making it all happen. And honestly, that's pretty cool. If you found this explanation helpful, go ahead and hit that like button. If you want more breakdowns of how the tech you use every day actually works, make sure you're subscribed. And if there's another networking topic you'd like me to cover, drop it in the comments. Thanks for watching, and I'll see you in the next